This is what happens when two people who know just enough to be dangerous join forces to create something cool. This is the Javelina. It's a two-stage FPV airplane that's launched from this tube right here with a rocket motor that can then be flown continuously using a ducted fan. And it's controlled right from where it's launched. This is the main control housing. It's a custom-made remote control that allows you to control the plane as well as see what the plane sees. This is something that my friend and I have been working on for the better part of a year, and this is a video to explain how it works and where we're currently at in development. So let's start by discussing how it works. All right, so this is an overview of the launch process for the Javelina. So let's start with the plane in its launch tube waiting for commands from the main control housing. The main control housing has two triggers. One is for arming and the other is for firing. So when a user presses the arming trigger, a command is sent to the plane to start preparing for launch. When this happens, the plane starts averaging stationary acceleration data so that it can compare the data to when it should be moving and be able to actually tell when a launch occurs. When the firing trigger is pressed, the main control housing both sends a voltage to the motor igniter and it also tells the plane that it should be moving shortly. In response, the plane waits for about 3 seconds to detect a significant change in acceleration. If it doesn't, the plane will fail-safe, and if it does, then the launch will continue as normal. At this point, the plane should have made it out of the tube, and it should be accelerating. This starts the second state. Now, the only thing holding the fins down is the tube, so as soon as it leaves the tube, the fins should fold out. Then the plane should continue to gain speed until the motor burns out. Now, the rocket motor is a staging motor, so as soon as the burn finishes, the ejection charge will immediately go off, and this starts the third state. When the ejection charge goes off, the first and second stages will separate, and the plane will begin to decelerate. This starts the fourth state. The plane should detect the loss in the acceleration from the rocket motor burning out, and then it will deploy the wings and allow the ducted fan to spin up. And this stage will have an override in case the plane doesn't detect this for whatever reason. You'll be able to just pull both triggers and deploy the wings and allow the ducted fan to spin up anyways. And then you can fly the plane continuously until the battery dies. If communication is ever lost between the plane and the main control housing, the plane will fail-safe and a parachute will deploy. So that's a basic rundown of the Javelina launch process. Now let's talk about the electronics that make this possible. So these are the electronics for the main control housing. The PCB you see under this mess of wires was my first attempt at using KiCad to create a circuit board, and it actually went super well. As you can see, this is version 0.1 right here, so I have had to make literally zero changes to this board. Absolutely incredible. At the top of the board, there are two XT30 connectors. One is for the battery, and the other one is to send a voltage to the motor igniter. Over here on the left is a relay board, and that is to allow the microcontroller to send that voltage to the motor igniter without blowing up any electronics, trying to send too much power. On the outskirts of the board, you can see a bunch of connectors right here. These are JST PH connectors, and they're used to control things like the display and radio, as well as read inputs from the two joysticks on the backside right here and the two triggers right here. The electrical taped blob right here and this white backplate are to make the A on the front of the main control housing glow with different colors depending on the situation. This was something I added in after the fact, so it's kind of hacked in here. And in the future, I guess I should make another revision of this board. Would include support for that. And then finally, the brains of the entire thing is an ESP32. It's probably overkill for the needs of this project, but I like them and they're super cheap, so that's what I went with. Next up is the plane's electronics. All right, so these are the electronics for the plane minus the brushless motor, which is still sitting inside the plane at the moment. Again, you'll see another PCB, except beautiful this time. It's black. Very good choice. This is the second PCB that I made in KiCad, and it's definitely a little bit more complex, but it's nothing crazy. So on the top left here, we have two XT60 connectors. This one is for the battery. It's a 4-cell LiPo. And this one is to connect to the ESC that will send the power to the brushless motor. And then here we have an integrated relay this time for powering the solenoid for the parachute bay. And over to the right here, we have two resistors. Those are for a voltage divider to read the battery voltage. And we also have a transistor and a diode so that the microcontroller can actually switch on and off the relay. And then just below that, we have control pins for the ESC here, as well as the solenoid for the parachute bay door. Then moving over to the right here, we have 3 buck converters that are for the different voltages and power requirements that are needed by both the plane's servos and the ESP32. 2 of these are for the servos because they're a little bit power hungry. There's more than 2. There's going to be like 6 of them. So I put 2 there just to make sure that nothing got too hot. And then this third one is just to step down the voltage from the battery here so that the ESP32 also doesn't blow up, because I've done that before. And then we can see obviously another ESP32, and it's surrounded by a bunch of, again, JST-PH connectors. Top ones up here are for this radio right here, and the bottom ones are for a bunch of servos. And then over here is the FPV system that I yoinked from a little baby drone that I've had lying around. And this is what I'll use so that you can see what the plane sees. I also threw a little fan on it so that it doesn't overheat, because it's not going to be getting any airflow from inside the plane. And yeah, those are the plane's electronics. And now we can move on to the plane itself. Okay, so this is a 3D model of the Javelina in its current state. My friend Justin is the one that designed this thing, so props to him. It looks freaking awesome. I did design this rocket motor stage back here, but everything else was made by him. If you want to support him, you can go and subscribe to his channel. It's just his name, Justin Nyman, and I'll also include a link in the description in case you want to do that. So I figured the easiest way to go over this 3D model would be to briefly cover the launch process again. So what you're seeing right now would be the state of the Javelina when it's in its tube waiting to launch. When it launches, the fins will fold out like this. These cavities right here will just have little springs in them that will force out the fins whenever it leaves the tube, and then the air resistance will just do the rest of the work. And then once the fin has folded out all the way, there is a magnet that sits right here in this hole right here. It's covered up by this piece because I haven't fixed that yet. So there's a magnet that will sit right here, and there's a piece of metal that will sit right in this slot right here. So the spring forces the fin out, and the air resistance will do the rest of the work. And then the fin will come in contact with that magnet, and it will stay like that. And I'll go ahead and fold the rest of them out. So now all of the fins have been folded out, and it's accelerating. It's also flying as an unguided model rocket at this point because the fins are not yet controllable. Then once the rocket motor burns out, the ejection charge will immediately go off, and the 2 stages will separate like this. So this piece at the end right here is what holds the rocket motor. It just press fits into the back right here and presses into this ledge right here when it's burning. And then if we look on the other side of this part, you'll see a little gap here between where the rocket motor sits, which is right here, and the rest of the part. There's a gap right here, and that is to hold a streamer. And that's just to help this stage to slow down once it separates from the rest of the Javelina. This middle piece in between the main body of the Javelina and the part that holds the rocket motor sits on top of the rocket motor like this on this ledge right here, and creates a loose seal so that when the separation charge goes off, this part goes flying forwards and hits the butt of the Javelina right here to help dislodge these 2 states. It also acts as a lid for the streamer to make sure that it doesn't come out whenever it initially starts flying. So then once the 2 stages have separated, the Javelina will notice the deceleration and it will let the wings fold out. And then it'll look like this. The notch at the tip of the wings right here and right here are so that a servo horn can just hold the wings in until they're ready to be released. You can also see back here that the wings are set one on top of the other, and that's so everything can fit in this super tight space. When the Javelina releases its wings, it will also allow the ducted fan to spin up, and it will also allow the fins to be rotated like this. There are servos under each of the fins that will sit right here. This hole right here is for a screw to go into the gear piece of the servo. And if for whatever reason a failsafe is declared, this door right here will open and allow a parachute to come out, and then it can just safely land on the ground. This hole here in the front is where the FPV camera will sit, and all of the electronics will be housed in this area right here. So this is the javelina in its current state, and you may notice that it looks very unfinished. And that's because a lot of very cool changes are coming just as soon as Justin is no longer being annihilated by college classes. Um, this thing in its current state is just too heavy. It's too heavy to fly. And also, while I was looking into rocketry regulations, if we want this thing to be a class 1 model rocket, it needs to weigh 1.5 kilograms or less, fully loaded, and it also needs to contain no substantial metal parts because, yes, we were making a custom metal rocket motor, which we spent forever testing. A moment of silence for all the testing that we did.
3, 2, 1. 2, 1. Three, two, one.
So the final question is, what's next? Well, as far as my side of the project goes, the main control housing is finished and the PCB design is finished as well, but the code still needs work to be fully functional. The secondary display inside of the FPV headset has a fully functional menu, and the main control housing can talk to the javelina just fine. But I still need to implement things like the motor control and the servo control, as well as the acceleration and deceleration detection for the javelina. And I'm sure a million other bug fixes along the way as well. So once I have a working beta version of the code, and as soon as Justin has finished a lighter model of the Javelina, we'll do some test launches and I'll make another video about it. The latest 3D models and code will be available on my GitHub page, and I'll leave a link to that in the description in case y'all are interested in looking into it and learning more about it. I want to hear what you guys think of the project and any suggestions that you have to make it better. Again, huge thanks to Justin as well. He made this entire other half of the project possible, and he did a freaking awesome job and is redesigning the whole thing to make it lighter. But yeah, that's it for now, and I'll see y'all again whenever we have some launches to share.